The topic of this day is VPC, that stands for Virtual Private Cloud. What is that? This is the VPC, that stands for Virtual Private Cloud. Now, what is this? See, the thing is, this is very important fact for you to understand, and you already know that whenever you decide that you have to deploy your infrastructure on AWS, AWS is a public cloud platform. Any cloud provider you pick Microsoft Azure, you pick Google Cloud or GCP, any cloud provider you pick, each of these different cloud platforms are public based. These are public cloud platforms. Now, you may say, why they're public? Because anyone, you, me, any individual, any organization is welcomed to come in. So they allow any individual, any organization to come in and start deploying the infrastructure, start deploying their infrastructure, their applications, their databases upon the same platform that is being used and shared by other individuals and the organizations. Fine. So now this means that this may hamper security of your infrastructure because you're sharing your platform maybe with your competitor. Your competitors are running the infrastructures on the same public cloud platform. So this may impose, or this will, I would say that this may be a big concern for you in terms of security. This may be a big concern for you in terms of security. So you may not be comfortable by looking into this entire picture because you are running your infrastructure on a public platform, which may not be secure for you. So AWS has come up with this feature, and I think this also exists on other platforms like Microsoft as well. This is called the VPC, or the Virtual Private Cloud. Now, what's the concept behind it? The concept is that they give you a portion of that public cloud which is completely isolated from rest of the infrastructures. It's completely cut off from the other infrastructures that are running on the same platform. So what is a virtual private cloud? Let's understand the basic concepts. A virtual private cloud is a virtual data center. What is that? It's a virtual data center. It's a virtual data center, and you get the full control upon its resources. You get the entire control upon its resources, the components, everything. You get the full control, and you get the flexibility, and this also facilitates the enhanced security. So it also gives you the enhanced security because you have a complete control upon the networking components. So this guarantees you the enhanced security. You get a lot of security in terms of transparency, because the thing is that you can easily see what is running in your infrastructure in that virtual data center. You can easily see what exactly is running, and based upon that, you can just make some changes. You can do some customizations, right? So it's a virtual data center. You get a complete control upon the components and the resources. You get the flexibility to change the things on your own, and also this guarantees you the enhanced security. That's the purpose of using the VPC or the virtual private cloud. Okay, so your VPC would be completely isolated from the other VPC because it's a virtual data center. it doesn't mix up. It doesn't just communicates with any other VPC by itself. Okay, so it's completely isolated, completely cut off. It is isolated. I would say that it is isolated from other VPCs. So no two VPCs by default, they will communicate with each other by themselves. It will not happen. So you have to open the channel. So you have to just configure a few things to have the two VPCs communicate with each other, whether those VPCs are in the same account or they may be in separate accounts. Fine. So I hope you understand the basic concepts or the principles. What's a VPC and why you need it. Fine. Now the thing is that there's one single statement that I want to stress upon, which is this one. That is, you get the full control upon its resources. Because the resources that I'm talking about, those are not the resources which are the resources you can get the physical access to. Those resources are the networking components. For example, so what kind of components you have full access upon? So those components are that you have full access upon. First of all, you get access to define the IP addresses. You can define the IP addresses, especially you can just specify or determine the private IP address scheme, or I would say you can specify the private IP addresses for your VPC and the subnets. The second component that you can specify and control and you can just define are the subnets. We'll discuss all these different components one by one. The subnets come into two different flavors or two different categories. One is the public and other one is the private. Fine. One is a public and other one is the private. Fine. The second component, the third one is, the third component that we have is route tables. We'll discuss all these things in detail afterwards. But right now, one thing I want to stress upon is that I want to just help you understand that what are the different components that you have to define one by one. So what you define? The route tables. Fine. Then the next thing that you define is, apart from the route tables, the next thing that you specify or you define is the internet gateway. Also, you specify the NACL, that stands for Network Access Control List. Network Access Control List. Fine. You specify the Network Access Control List, and you specify the virtual private gateway. I'll discuss all these things one by one afterwards. Virtual private gateway / customer gateway. Fine. So define the IP addresses, subnets, route tables, internet gateway, network access control list, virtual private gateway, or the customer gateway, right? So these are some of the components that you specify on your own one by one. So you understand, or you have to understand the functions of each one of them, and based upon the functions of each one of them, you can easily specify exactly that how to formulate and structure each one of these different components. So we have the IP addresses, subnets, route tables, gateways, access control list, and the virtual private gateway or the customer gateway. So we'll discuss all these things one by one in detail. Fine. So as of now, we have discussed the basic concept behind the VPC or the virtual private cloud. And after that, we have discussed that what are different components that you specify, that you define one by one. There's one thing I missed over here. The next thing that you define is the NAT device. NAT device comes in two different flavors, NAT Gateway and NAT Instance. We'll also discuss in detail afterwards. So these are 6 to 7 different components that you define, that you specify one by one by yourself. Okay, so we'll discuss that afterwards. Now, let's do one thing. Let's start understanding the different types of components. I start with the IP addresses, and then once we understand the components, then I'll just show you the entire configuration part. That is the deployment of the VPC. Fine. We understand the components. After that, we discuss the difference between the default and the non-default VPC, and then we configure the custom VPC or the non-default VPC from scratch. Okay. So let's first understand the components or the components of the VPC. So the first component of the VPC is our IP addresses. What are they? These are the IP addresses. Now, what are the IP addresses and why we need it? So first of all, any machine, any server that's there on the internet, or that wants to be the part of the network, has to be assigned an IP address. Your computers are using to join this conference is on a network, and your machine is getting an IP address. There are two IP addresses that you can assign to any specific device: a private IP and the public IP. But in AWS, there's also a third category that's called the elastic IP address. What is that? That's the elastic IP address. Fine. Okay. So let's start, or let's let's understand the first type of IP address, that's called the private IP, not the public. We will discuss the public afterwards. The first type of IP address is the private IP. Now, what's a private IP? Private IP is the one that's purely used for internal communication. So the private IP address is being used purely for internal communication. Fine. It's purely used for the internal communication. What do you mean by internal communication? If two different instances or the servers or the databases, they are in the same VPC and they want to communicate with each other, they will use the private IP addresses. Okay. So it's being used for internal communication. Now, if you assign any instance, if you assign it a private IP, or I would say the private IP is not being reached over the internet. You can't access the private IP over the internet. So the thing is that it's purely used for the internal communication. Now, we define the ranges for these private IPs, and these are generic, or I would say these are the same for every type of infrastructure. So this is the industry standard. So the ranges that we specify for the private IPs are, first one is 10 172.x.x.x. Then we have 172.16.x.x. It will go up to 172.31.x.x. Then the next range we have is 192.168.x.x. These are the three IP address ranges that fall under the private IP. Okay. Now over here, X represents any number between 0 to 255. Fine. So you have to make use of any one of this range or ranges to specify the private IP address scheme of your VPC. So what's the purpose of private IP? It's used for internal communication. Now the next question releases that how the instance will get the private IP. So basically, let's suppose that this is your instance. The question releases that how it will get the private IP. So an instance will get the private IP depending upon the range, or I would say depending upon the private IP block assigned to VPC and subnets. So depending upon the range of the VPC and the subnets, the private IP address of an instance is being determined. We'll discuss that in detail afterwards, but right now what you have to understand is that the instance will get the private IP depending upon the range of the private IPs assigned to the subnet and the VPCs. Okay, so what happens is, I'm just giving a very small example. Let's imagine this is my VPC. This is my VPC and this is my subnet. The VPC has a range of 10.0.0.0/16 and subnet has a range of 10.0.2.0/24. Now the instance, the EC2 instance or any database instance that I configure and deploy or launch in this subnet may get the private IP of, for example, 10.0.2.2/32. So the IP address range of the VPC and the subnet, it is a big factor to decide or to determine that what should be the IP addresses of the instances running within them. So the instances running in the VPC and the subnet, they inherit or extract the IP addresses because they are being launched in the subnets and the VPCs. So they get their private IP addresses from there. They get the private IP addresses from there. Okay. So the range of the VPC and the subnet, these are the two biggest factors to decide upon the private IP addresses being allocated to each and every instance running within them. The second category of the IP address that we have to understand is the public IP. Fine. Now, as the name implies, the public IP is used for external communication. If you want to expose your resources to the internet, so it's external/internet communication. So the thing is that if you want to expose your instances to the internet, then you allocate the public IPs to them. Now, what are the ranges they fall into? So any range except the private IPs 1, I've already shown you what are the different ranges for the private IPs, and except loopback IP, which is 127.x.x.x. So this is the loopback IP address. Okay, loopback IP means that it's used for troubleshooting. It's a loopback IP address. So except these two different specific ranges, any of the IP address can be the public IP. Now the next question really is that who assigns the public IP? For example, if this is my instance and I assign a public IP, what's the deciding factor? See, the public IPs are being allocated by the AWS or your internet service provider. AWS or the internet service provider. Now, AWS has come with a concept where you can just bring your own IP and you can use those IP addresses which you have purchased from your internet service provider and use them as public IPs in AWS. Or you can just get the public IPs from AWS directly without any cost. Because AWS, they give you the public IPs for free of cost. But if you already have some spare public IPs that you have purchased from the service provider, you can bring them to AWS. This is a new concept they've come up with. I haven't seen anywhere used as of now, but this is a new concept. Fine. So the main purpose of the public IP is that it's being used for the external communication, or it's being used to expose your instances to the internet. Now, these are the different concepts behind the public IP, but the public IP has a major downside. What's the downside of the public IP? That is, it is not static in nature. It is not static in nature, it is dynamic. It is not static in nature, it is dynamic. It will change itself after, if you restart the instance, it will change if you just restart the instance, or maybe that you have launched an instance. So if you launch an instance or you restart the instance, it will get a new public IP. I'll cover that afterward. So the main downside of the public IP is that it's not static in nature. Now, if it is not static in nature, how it can be a concern for you? See, let's suppose that you're dependent upon only one single instance to host your web application or the web server. For example, you have this single. So this is your VPC. This is your subnet, and this is my instance upon which I'm running a WordPress site. Let me just write it down once again. That's my WordPress site. Now, I want the external users to reach this instance. They will just type in xyz.com, and xyz.com should resolve to the public IP address of the instance. This is being done by a DNS service. In AWS, the DNS service that we use is Route 53. We will discuss that afterwards. So we use a DNS service to convert the domain to the public IP address of that instance upon which the WordPress site is being hosted. The problem is that if this instance restarts, it gets a new public IP. If it gets a new public IP every time, then in that case, you have to change your DNS entries. You have to change the domains settings every time. So let me show you this one thing. Let me just go back to the AWS management console, and let's go to EC2 under the compute section. Let's go over there. And I don't have an instance running right now. Okay, this is instance. These are some of the instances that are being stopped. Let's pick this instance. Right now, this instance is stopped, and the only IP address that it has is the private IP and the private DNS name. Now, the private IPs or the private DNS, they are interrelated. They never change. They are static in nature. Now, whenever you launch a new instance, or you just start a new instance, it automatically gets a new public IP. Let me show you. So I choose this Amazon Linux AMI instance. I go to actions and I go to instance state and click on start. Click yes, start. So it will take a few seconds for this thing to show me the public IP. And as you can see that it automatically is showing me the public IP address. It is showing me the public IP address. Fine. And this is the relevant or related public DNS name. Fine. Now the thing is, over here, let's copy this public IP and just paste it to this text document. Fine. So this is the public IP address of this instance right now. Let's do one thing. Let's stop this instance and let's see what happens. Let's see what happens to this public IP once I stop this instance. Let's wait. Okay, now as you can see, this instance is stopped completely. And where's the public IP? It's gone. It is permanently gone. And if I just restart this instance, you will see that it will get a new public IP. Now, the question really is, why it is so? Why the public IP is gone? See, the thing is that whenever you stop the instance or terminate the instance, there's no relevance of the public IP, because anyhow, any machine that's being stopped, any server that's being stopped, it can't be reached. Makes sense? So in that case, AWS, they disassociate the public IP address instantaneously or immediately once you stop the instance. So this thing you have to understand. Public IPs are being controlled by AWS. They're being controlled or managed by AWS. So as soon as you stop the instance, they will just remove the public IP, and they manage the pool of public IPs behind the scenes. They will just manage it by themselves. And if I just restart the instance, you can see that it just got a new public IP. If I just copy and paste that over here, you will if I draw the comparison for you, you will see that it's different. Can you see the comparison? This is the previous public IP. This is the new public IP. So this means that just in case, if you are not using any type of load balancers and auto scaling, and you're dependent on a single instance to host your static website or any website, then in that case you have to change your DNS entries every time the instance restarts. Fine. Now, to solve that situation, we come up with a new concept, or I would say, to counterattack this situation, you make use of a third type of IP that's being termed as the elastic IP. Elastic IP is the same as public IPs. They are same as public IPs, and they have the same. So let's write down once again. So the elastic IP is the same as public IPs. They have the same purpose. Elastic IPs, they are same as public IPs. They are being used to expose your instance to the internet. They're being used for external communication. However, they are as opposed to as compared to the public IP, they are static in nature. They never change. Even if you just stop and start the instances multiple times. Okay? And they are controlled by customer. So you have an advantage because you can control and manage the allocation of the elastic IPs. And elastic IPs are account specific IPs. So they are associated to your account directly, not to instances. And that makes a big difference. So let's do one thing. Let's go back to the this AWS management console, and as of now, I just focus on this instance, this one. Okay, this instance already has a public IP, which is this one. I want to assign it an elastic IP so that every time this instance restarts, the elastic IP, which is equal to the public IP, never ever changes. So what I will do, I just go to the elastic IPs on the left hand side under network and security, just under the security groups. I go to elastic IPs right now, and I get this thing, allocate new address. I click allocate, click close. As of now, what we have done so far is that we have allocated an elastic IP to our account. We have allocated an elastic IP to our account, but it is not being allocated to any instance right now. If you see right now, it's not assigned to any instance. So I choose my elastic IP, go to actions and click on associate address. I choose my instance. I choose the private IP address of the instance, and you can see a warning message. This says, if you associate an elastic IP address with your instance, your current public IP address is being released. So what it says is that whenever you just assign an elastic IP to any existing instance which already has a public IP, this thing you have to keep in mind. The existing public IP address is being released. So this means this public IP would no longer be the part of that instance. Plain and simple concept. So I will assign this elastic IP to the instance which already has this public IP. Once I do that, this public IP address is being released. It goes back to the pool of public IPs being maintained and managed by Amazon Web Services behind the scenes. I click on associate and click close. Now I just go to my instance dashboard by clicking on instances on the left hand side, and as you can see that I have just allocated an elastic IP, this one, which is equal to its public IP. So the elastic IP becomes its public IP. The elastic IP becomes its public IP. Now, if I just stop the instance, restart the instance, you will see that it will not change. Why? Because the life cycle of the elastic IP is not dependent on the life cycle of the instance. Reason being, elastic IPs are the account specific resources. This thing you have to understand. Elastic IPs are the account specific resources. This single concept or difference makes a huge impact as to how the elastic IPs can be used. Now, as you can see that the instance is completely stopped. It is completely stopped, and the elastic IP, which is equal to the public IP, is not affected at all. If I just start it again, you will see that there will be no change. Okay, so the elastic IPs are static in nature. They have the same purpose, exposing your instances to the internet, but they come with a advantage, that is, they are static in nature. But anything which has an advantage may have some downsides, and the elastic IP also has certain downsides and limitations. So, what are the limitations of using the elastic IP? The limitations are that you get only 5 elastic IPs per region. Okay, even though you get it for free. And also, so this means that this is the maximum limit. This is applicable to any account type. You get 5 elastic IPs per region, which you get for free, and this is the maximum limit you can go up to. So at any given point of time, you cannot accommodate more than 5 elastic IPs, which you get for free, and this is the maximum limit you can go up to. Okay. Now the thing is that they say that they give you for free, but there's a terms and there are some terms and conditions being imposed upon you. What they say is that maximum you can have up to 5 elastic IPs at any time for free of cost, but make sure that you don't assign these elastic IPs to stopped instances for longer duration, and don't allocate these elastic IPs or to, for example, okay, let me just come back once again. First of all, the elastic IPs should not be assigned to stopped instances. And also, they should not be sitting idle, which means that they're just sitting over there and they're not being allocated to any instance right now. They're just sitting over there and they're not allocated to any instance. Fine. If you have the elastic IPs allocated to stopped instances for multiple hours, and the same goes with the idle, or I would say the elastic IPs which are unallocated and they're not being associated to any instance, and you do that for more than an hour, then they will start charging you. So let me just give you one simple example. I go to the elastic IPs dashboard on the left hand side. Okay, I go to actions and click on disassociate address. I click on disassociate address once again. Now once I disassociate the elastic IP from any instance, immediately Amazon Web Services will allocate a new public IP address to that instance. Okay, now the thing is that this elastic IP is sitting idle. It is not doing anything. It is being unassociated. Right now, it is being allocated to my account, but it is not being associated to any instance. That's fine. If I keep it like this for more than an hour, they will start charging me few cents per hour for this elastic IP being unassociated and not doing anything. Okay, and also if I assign this elastic IP to any stopped instance for more than an hour, they will start charging me few cents every hour. Now you may ask this question that what kind of billing model is this? Once they give you 5 elastic IPs for free, and that they impose these weird or these kind of restrictions for you to pay for them. See, why they come up with this kind of billing model? The reason being because there's already a shortage of the elastic or public IPs in the networking world or domain. There's already a shortage of the public or elastic IPv4 addresses. That's why we are moving to the IPv6 addresses. So to ensure that you just use them properly and you don't waste them, there's no wastage. So they discourage any kind of wastage because these are scarce resources. There's a scarcity of these resources. So they say we give you 5 elastic IPs per region, but ensure that you don't allocate these elastic IPs to stopped instances and don't make them or have them sitting idle for longer duration. If you do that, we will charge you. Okay. That being said, this completes the conversation on the IP addresses. So let me just go back. So what we had discussed as of now, we have discussed 3 types of IP addresses. One is the private, the other one is the public, and the third one is the elastic IP address. So these are the 3 different types of IP addresses that you're going to be using to structure the entire VPC or the virtual private cloud. The second component that we will discuss right now is the subnet. What is a subnet? A subnet is a complete range of private IPs. It's a complete range or it's a complete block of private IPs. It consists of instances, okay, and each subnet is associated to a specific AZ. Okay, so a subnet is a complete block. It's a complete range slash it's a complete block of block or range of private IPs. It consists of instances, and each subnet is being associated to a specific AZ. Fine, that's the main concept, or this is the main essence behind having the subnets. Now the subnets, they have 2 different categories. There are 2 types of subnets. One is the public subnet. A public subnet is the one that consists of your public based resources. For example, your web servers. And the second category that we have is the private subnet, which consists of the private based resources. For example, your databases. Okay, so these are 2 different subnets that we have. One is a public subnet, which consists of the web servers or anything that's being exposed to the internet or the public users. And the private subnet is the one that you want to keep isolated from the rest of the infrastructure. Okay, I'll give you the exact differences once I start moving with the concepts one by one. So as of now, you have to understand there are 2 different types of subnets. First of all, what's a subnet? It's a complete range or block of private IPs. Each subnet will consist of instances, and each subnet is associated to a specific AZ or the availability zone. And the subnets are being further divided into different categories. One is a public subnet, which consists of the public-based resources which you want to expose to the internet. For example, the web servers. And then we have the private subnet, which should be completely cut off from the internet. For example, the databases. Fine. As of now, just understand these two different concepts. Once I start giving you the understanding of the gateways, then you will understand subnets in a much better way. Fine. The third component that we discussed right now is the Internet Gateway. An Internet Gateway is a gateway which opens the access to the internet. Okay, it provides internet access to the VPC. So the internet gateway is being allocated so that the VPC can access the internet, and also it allows the communication between the different servers inside the VPC. But basically, it exposes your VPC to the internet. Okay, you have to have the internet gateway if the VPC has to access the internet. Without the internet gateway, the VPC is not attached, or I would say it cannot communicate with the external world or the internet. It has to be there. Okay. Now by default, you just assign only one IGW or internet gateway to one VPC, which is more than sufficient. You don't have to assign multiple gateways to a single VPC. One single gateway will solve that purpose. Fine. So that's about the internet gateway. The fourth component that you have to understand is the route table. And after that, I just amalgamate all these concepts in a single diagram. So what's the route table? Route table is a set of routes, okay, which determines how which determines how the network traffic will flow in and out of a VPC. So it's a set of routes which determines that how exactly the traffic will flow, the network traffic. Let's write down once again. This is my network traffic. How the network traffic will flow in and out of a VPC. Basically, it's a kind of a GPS. If the traffic wants to flow internally or externally, it has to make use of the route tables. It is a set of routes which determines that how exactly the traffic will flow in and out of a VPC. Okay, let's do one thing. I just draw an example for you, a small figure where I just amalgamate all the concepts, the subnets, internet gateway, and the route tables. Let's do that. This is my VPC. Okay, let's imagine. So the thing is that the VPC is the region specific resource. So as of now, I'm in Mumbai, and this is my VPC with an IP address range 10.0.0.0/16. /16. This is the IP address I've assigned to my VPC. Now, what this /16 means, we'll discuss this afterwards. Then we carve out two different subnets. Now, what's a subnet? It's a complete block or range of private IPs. This would be my public subnet. I associate to one of the AZs in Mumbai, that is AP South 1A. Then we have the private subnet that I associate to AP South 1B. I can go with the same or different one, it's up to me. Now, in the public subnet, I deploy my web servers. These are my web servers. And in the private subnet, I deploy my databases. Fine. Okay. Now, the thing is that as of now, this entire VPC is completely cut off. So the thing is that this entire VPC is completely isolated. The resources can talk to each other internally. That's fine. But as of now, this is completely your virtual data center. It's completely isolated and cut off from rest of the world. It is completely cut off. So the resources can talk to each other internally, but there's no channel for it to communicate with the outside world. So the question really is, what do we have to do? The answer is extremely simple. The answer is that, first of all, what you do is that you have to allocate the public / elastic IPs to the resources running in the public subnet. So to expose any instance to the internet, you need two things. First one is that you need to allocate the EIPs, elastic IPs, or the public IPs to them. If you want IPs to it, if you want to expose any instance to the internet, you have to allocate the elastic IP or the public IP. Okay, that's the first thing. That's the first thing that you have to do. So I want to have these web servers to be exposed by the internet users. So what's the internet? It's the biggest public cloud. I have the users on the internet. They want to access my web servers. Okay. Now the thing is that there should be some gateway or channel to have this VPC access the internet, because as you can see, these are two different clouds. Internet is the biggest public cloud, and VPC is your private cloud. Now you place the IGW or the internet gateway, which is a virtual gateway, and you link it to the internet. Okay, you link it to the internet. So the second thing that you have to do is that to expose any instance to the internet is that it should be launched in a public subnet with access to IGW. If you miss any one of these two different conditions, you cannot expose your instance to the internet. You can't do that at all. So these two conditions should be fulfilled at any cost for the web servers running the public subnet. So you have to fulfill these conditions for the web servers running in the public subnet. It's extremely important that you do that. If you don't do it, then the web servers running in the public subnet would be completely useless. So first thing first, how to expose these web servers to the internet? First thing, you have to allocate these servers the public IPs or the elastic IPs. A second thing is that they should be lodged in a public subnet with access to the internet gateway, because the public subnet has access to the internet gateway. Okay, what's the internet gateway? It's a virtual gateway that opens the channel or access to the internet. Now, this linking of this internet gateway with the public subnet is done by a specific feature or the resource that's being named as a route table. So this linking process is being done by route table. Okay, it links the internet gateway to the internet. It links the resources in my public subnet to the internet. It's like a GPS. It's like you are establishing a channel so that these instances will understand that if they have to reach the internet, they have to go through the internet gateway. Okay, so this is the basically the essence of the basic VPC infrastructure. If you understand this thing, I think half of the concepts are clear. Half of the battle is already won, or you already understood half of the, I would say almost all the concepts, because this is the essence of it. Okay, so you have understood almost all the concepts, or I would say you have got the essence of it, the crux of the VPC. You have got the crux of the VPC. So this is very, very important. Now, as I move forward, I'll explain you the things again and again, because right now I'm just giving you the basic stuff. So once we move forward, we'll understand the concepts. To reiterate, the route table is basically it's a set of routes that's been used to determine that how exactly the traffic will flow internally and externally of the VPC. Even the internal communication is being determined by this route table. How the traffic will flow in and how the traffic will flow out is being determined by the route table, which is the set of routes, which is a set of routes. Okay, so this is the essence or the crux of the VPC or the virtual private cloud. Fine. So let's understand the other different concepts. Fine. Now, one thing that's very important, if you look into this private subnet, we don't allocate any of the elastic IPs or the public IP addresses to any one of the instances in this private subnet. We don't do that. Okay, and that's the reason this is completely cut off from the internet. This portion is completely cut off from the internet. It has no access to the internet whatsoever. But yes, this portion, it has complete access to the internet. Fine. So these are the few things we discussed. We discussed about the IP addresses, the public, private, and elastic IP addresses. We discussed about two different subnets, public and private. We discussed about the route table, which are the set of routes. And then we discussed about the internet gateway, which opens the channel or it's a gateway to the internet. Fine. So these are the concepts that we have discussed so far. The next thing that we have to discuss, so we have discussed the IP address, subnets, route tables, and internet gateway. The next thing I'll discuss with you straight away is this one, NAT device. NAT device we have to discuss. It's very, very important. See, NAT device, first of all, it's an optional feature. You may or you may not go with this. It's up to you. What's a NAT device, by the way? let's understand the concept first, and of course once we move forward, we'll understand the other things. Okay, so I think this was fourth concept. Let's understand the fifth concept. NAT, that stands for network address translation device. What is this? See, the main purpose of the NAT device is that it helps. Let's try it once again. So let's understand the purpose of the NAT device, because this is an optional feature, but it is important if you need it for the databases to download the updates. So this helps the instances in the not public, I'm sorry, in the private subnet to download the patches / updates. Okay, and even though this is being used by the instances in the private subnet, it's been launched in the public subnet, and you associate an elastic IP to it. Okay, so the NAT network address translation NAT device, it helps instances in the private subnet to download the patches and updates. It's been launched in the public subnet, and you associate an elastic IP to it. So what's the use of it? I just draw an example, I sketch an example for you to understand this concept. Let's imagine this is my same VPC, right? So this is my Mumbai VPC with the range 10.0.0.0/16, fine. And this is my subnet A that belongs to AZA. So this is my public subnet. And on the other hand, this is my subnet B that belongs to AZB, and this is my private subnet. Now let's suppose that in the private subnet, this is my SQL DB instance. This is the my SQL DB instance, fine. And in the public subnet, I deploy a NAT device. Okay, and then I have this IGW, and then I have this internet. Okay, let's imagine this MySQL database, this one, has to download some updates. For example, I have put that into the auto maintenance mode, and it has to download. It has to download some updates or the patches. Now the thing is that in that case, what happens is, first of all, this NAT device, which has been launched in the public subnet, will have the elastic IP or EIP assigned to it, and this my SQL database will have the private IP. For example, it has a private IP of 10.0. Let me just write down once again. Like for example, 10.0.2.2/32. Fine. So what happens is this MySQL database has to download some patches or updates. It will communicate with the NAT gateway internally, and that's being facilitated by the root table. You specify the root table for that subnet, for the private subnet, which will consist of the route saying, hey, you want to reach the internet, you want to access the internet, just communicate with the NAT device. It will open a channel of communication with the NAT device, and the NAT device will forward the request to the internet. Okay, so once again, I just repeat this entire stuff. The MySQL database will communicate with the NAT device, and this is being specified by the root table. Then the NAT device will forward that request to access the internet straight away. It will just pass it on. But in that process, it will do one important stuff. It will change the source IP to its own elastic IP. So basically, what should be the source IP in the real sense? This one. But I want to conceal or hide the complete private IP address scheme of the databases running in the private subnet. So once the traffic goes out, the NAT device will present its own IP as a source IP. So if there's a hacker sitting on across the internet, he will not be able to see from where exactly the traffic is coming, because he will not be able to comprehend the private IP address scheme of the databases running behind the scenes. So the NAT device will change the source IP to its own elastic IP. It will act as an imposter, saying, I am making this request. Now, once the response traffic comes back, it hits the NAT device. The NAT device will forward it to the exact MySQL database by changing the destination or the target IP to the private IP address of this MySQL database, so that the response traffic hits the exact MySQL database. That's the reason it's called the NAT, Network Address Translation. It is used to translate the IP addresses as soon as the traffic goes through it or cuts off through it. Once the traffic goes through it, it changes the private IP address, or I would say it changes the IP address of that traffic. So I repeat this process once again. What happens is, if this MySQL database, it tries to communicate with the internet, the request goes to the NAT device. In that process, once the traffic goes to the internet, the NAT device will present its own IP as its own elastic IP as a source IP. And once the response traffic comes back, hits the NAT gateway, the NAT gateway will change the target IP or the destination IP to the private IP address of the MySQL database, so that the response traffic or the updates are being downloaded to the exact MySQL DB instance. MySQL DB instance. So in this entire process, the main thing it does is that it conceals or hides the private IP address schemes of the databases running behind the scenes, and they can safely and securely download the patches. Fine. Now the thing is that the NAT device, it comes in two different flavors. One is the NAT Gateway, and the other one is the NAT Instance. What's the difference? The difference is very important for you to understand. NAT gateway is a virtual gateway. And this is an EC2 instance. Okay. This is more stable. This is less stable. This is more redundant in nature. This is less redundant. Okay. And the NAT gateway is a managed service. Managed service means that its redundancy, backups, failover, administration is being done by AWS. So it's managed service means that it's managed by AWS. But the NAT instance is being managed by the customer. Okay. Then the next thing is that the NAT gateway, it requires less administration efforts, but for the NAT instance, you have to perform a lot of configuration. Okay. And the NAT gateway is highly available resource because a managed service, it is highly available resource. Okay. As compared to this thing, and this is I would say not stable as compared to gateway, not as stable as compared to gateway. Fine. This is not that much available or highly available, and this can take care of the, if you have the higher bandwidth needs, it will take care of that. It can just take care of the higher bandwidth requirements. But this is not capable of higher, or I would say high bandwidth needs. So this is not that much capable enough to take care of a lot of traffic, capable of high bandwidth requirements. Fine. So these are differences between the NAT gateway and the NAT instance. So the NAT gateway is preferred over the NAT instance. NAT gateway is a virtual gateway. It's more stable, more redundant. It's a managed service, needs very less administration efforts, highly available. It can just suit your higher bandwidth requirements. It can just cater to the higher bandwidth requirements. But on the other hand, the NAT instance is not capable of the high bandwidth needs or the network, whatever you have. Fine. So these are two different types of devices. So the NAT gateway is preferred over the NAT instance. NAT gateway is preferred over the NAT instance. So what are the two different types of VPCs you have? The two different types of VPCs you have is default, and the other one is non-default. Non-default. Okay. The difference that you get is the default is the one that's being managed by AWS. Okay. And non-default is the one that's being created and managed by customer. Okay. Now, non-default is also called as custom/regular. Okay. Now, you have used the default VPC up to now, up to this point. We have done so many sessions. We have performed so many demonstrations, and we did a lot of practical sessions. We did a lot of practical stuff. So far you've been using the default VPC. Let me show you. If I just I just click on instances right now. Okay, I just click on instances. And I click on launch instance. I choose my EMI. I choose my instance type. Okay. Now the thing is that without giving it a thought, without thinking about what the VPC is, it automatically populates the default VPC for you. The default VPC for you. You don't have to think about it. So default VPC is the one that's there by default. If you don't have the custom VPC on your own, at least you have something to start with. Now I'm saying at least you have something to start with. This means it has certain downsides. The downsides are that every subnet is public. Every subnet is public in nature. There's no concept of private subnets over here. So this gives you the lesser amount of security. Every subnet is public. Let me show you one thing. I go to Mumbai and I go to the services and I just go to the VPC under the networking and content delivery. Now in each region, you can have up to 5 VPCs, including the non-default one. So I go to the VPCs in Mumbai, and this is my, this is on the top. Can you see that? This is my default VPC. Let me remove this custom VPC because we don't need it as of now. Let me just remove it. Okay, hang on one second. Let me just delete this thing. And let me just go to the VPCs. Let me just delete this custom VPC. We don't need it anymore as of now. Okay, so this is my default VPC in the region of Mumbai. This is my default virtual private cloud in the region of Mumbai. This is what we have. Now the thing is, if I just go to the subnets on the left hand side, these are the 2 different subnets that are the part of the same default VPC, and each of these subnets are associated to separate AZs in my region of Mumbai. So can you see that? I have 2 different subnets, and each of these subnets are the part of the AZs or the availability zones in the region of Mumbai. So I have that. Now the thing is, if I choose one subnet out of these 2 and choose the route tables, let me do one thing. Let me just remove this thing because I don't want any confusion to happen. Okay, so the thing is, if I just go to this route table, so for this, with the subnet you have to associate one route table. That route table, you just ignore this route. Or let me do one thing. Let me just manipulate them because I don't want any confusion to be in this entire conversation. So if I just go to the subnets and I choose the first subnet, choose a route table, it will consist of 2 routes. One route is a local route. Local route is the one that facilitates the internal communication. By default, every instance can communicate with any other instance in the same VPC. Irrespective of these subnets, each and every instance can easily communicate with any other instance in the same VPC. It can be launched in the public subnet or the private subnet. It doesn't make a difference. Every instance can easily communicate with any other instance in the same VPC. Fine. The second thing is that we have the access to the internet. Now this is the internet IP address 0.0.0.0/0. And this entire access to the internet has to be done through this IGW, that's the internet gateway. Okay, this means that the resources running in this subnet will automatically get access to the internet. Similarly, if I show you the other subnet of the same default VPC, I'll show you right now. And once I go over there, you will see that the same route table is associated, the same route table which allows the local or the internal communication and also access to the internet through or via the internet gateway. So what we conclude over here, the essence or the crux of this entire conversation is that every subnet in the default VPC is a public subnet. Every subnet is a public subnet. There's no concept of private subnet. Okay, and if it is go to the internet gateways, this is the internet gateway that's being attached to my default VPC, but it's being linked to both the subnets, which are now the public subnets, because all these subnets, both these subnets have access to the internet gateway. Fine. So every subnet is a public subnet. That's very important for you to understand. And the next thing that you get in the default VPC is that every instance, each and every instance, so I would say each instance will get public IP by default. And you have already seen this thing. Whenever you launch an instance without giving it a thought, the instance automatically gets a public IP. Now, the thing is, you fulfill both the prerequisites. What are those prerequisites? If I go back, what are the two prerequisites or the two conditions that you have to fulfill to expose any instance to the internet? Let's go back to the same concept. First one is that you have to allocate the elastic IPs or the public IP addresses to the instance. And then you have to launch this instance in the public subnet, which has access to the internet gateway, which has access to the internet gateway. Now, by default or automatically, these two different conditions are being fulfilled in the default VPC. So there's no concept of private subnet over here. Every instance is launched in the public subnet, which has access to the internet gateway, and every instance will automatically get the public IP. Okay, so this is not as much secure. So the thing is that you lose the flexibility, and this is less secure. Fine. Now, on the other hand, if you go with the non-default VPC, you have the concept of private subnets and public subnets both. So you can create different layers of resources. Layers means that you can keep your web servers in the public subnets and you can keep your databases in the private subnet. Okay. Second thing, a third thing which is very important, that there's no concept of public IP over here. You have to depend on EIPs in this case. In case of non-default or the custom or the regular VPC, there's no concept of public IPs. You have to depend upon the elastic IPs. This gives you flexibility, and this is more secure because you can deploy your databases in the private subnet of the VPC. This is more secure as compared to the default VPC. Fine. So these are the two main differences. Now, as per the best practice, you should never ever delete or modify or manipulate any of the parameters of the default VPC, because afterwards it is kind of difficult for you to restore it to the original format or state. So you should not delete or modify any of the parameters of the default VPC. If you want to have the customizations, it's better that you go with the deployment of the custom VPC. Fine. You go with the deployment of the custom VPC. That's the main thing. All right. So you have to go with the custom VPC in that case. So this is very important for you to understand the differences between these two different VPCs. Fine. So that's why whenever you deploy anything in the default VPC, by default it's accessed by the internet. Whenever you use SSH or RDP, you're using internet as a medium to connect to that instance, because it's been launched in the default VPC. Fine. So we have discussed all these different parameters. The next thing I will discuss with you is the network access control list, the fifth point, this one. What is this? See, I'll show you the configuration afterwards, but I just give you the essence of it, that what is this network access control list and what exactly this is. So the next thing that we'll discuss is the NACL, that stands for Network Access Control List. What is this and why you need it? Let's understand this point. See, it is very, very important that you include a lot of security options to enhance the security of your infrastructure. It's very, very important. So in that case, you make use of another virtual firewall that you apply to the subnets. We have another virtual firewall. Those are the security groups. Similarly, you can make use of the network access control list. These are the virtual firewalls that you apply to the subnets. Now, what happens is, let's take a very small example. Let's imagine this is my VPC. In Mumbai. And this is my subnet A that belongs to AZA. And this is my EC2 instance, right? Now you make use of a firewall that's called the security group, through which you restrict or filter the incoming and the outgoing traffic with respect to the instance. What you do? You make use of the security group. You apply that to the, I'm sorry, let me just correct it over here. So you apply to the instance, not to the subnet. Let me just, okay. So what you do is, this is my EC2 instance. So what you do is that you restrict the incoming and outgoing traffic with respect to the instance. This is my instance. So I think let me just try it again to make it more clear, because this is a bit confusing. So this is my subnet and this is my instance. So what you do is, you restrict the incoming and outgoing traffic with respect to the instance to the security group. And then, on the other hand, you restrict the incoming and the outgoing traffic with respect to the subnet to the NACL, or Network Access Control List. This one firewall which you implement at the instance level, which is the security group. There's another firewall that you apply that at the subnet level, which is the Network Access Control List. Okay. Now the question really is, in what scenarios these two different things fit in one single infrastructure? See, the thing is that at the Network Access Control List, you allow or you deny the major chunk of traffic. And at the security group, you go precisely by instance. For example, let's take a very layman example. There's a campus. At the border of the campus, there's a entry gate. At the entry gate, there's a security guard. Now, the purpose of that, or the intent of that guard, is that he only allows the students who belong to the campus to enter through the gate. And the other people who are not the part of the campus are not allowed to come in. Fine. Now, once these students get into the campus premises, they disperse and they go to their respective individual departments. For example, a student who is learning physics will go to the physics building. A student who's not learning chemistry will just only go to the premises where he can be taught chemistry. The person who's understanding neuroscience will just only go to the respective department. So once the students disperse, they go individually and they just go to the respective buildings or their departments. It works in the same way over here. The Network Access Control List is a security guard which is sitting at the border of the campus. It allows or denies the major chunk of the incoming traffic. So for example, I'll just give you a very small example right now. At the Network Access Control List, I allow HTTP, I allow RDP, but I block SSH to come in. Okay, so SSH can't come in. SSH will not be able to enter into the subnet. Now, at the instance level, I can either allow the HTTP or RDP. But if I implement SSH, will it work? The answer is no. Because anything that is being blocked outside, how can it come in? Makes sense? So you block any traffic which you should not be allowed to come in. And at the instance level, you go precisely instance by instance. So you double the amount of security. See, you may have seen this thing if you in a very common, I'll just give a very common example. You go to a very secure zone, maybe to a defense area. So you have to go through 3 checks, so that if somehow you skip the first check and there's something that has to be looked into, then in the second check, it can be just taken care of. They can catch you just in case if you're just carrying something which is not allowed to come into the premises. So you have to go through 2 checks, 3 checks to ensure that only the authorized person can come into the secure zone. So the same concept applies over here. You apply 2 checks for the traffic to come in or go out, so that once the traffic has passed the first check, you can also see whether it can just go through the second check or not. So the first check is the access control list, and the second check is the second security check is the security group. So you apply 2 different filters and the restrictions. Okay, we'll discuss the configuration of the network access control list in detail afterwards. Okay, so we have discussed this component. We have discussed this component right now, which is this one, 5th one. The 6th component that we have to discuss is the gateways. Okay, let's do one thing. I'll discuss with you the gateways afterwards, because we can just start with the deployment in the next 45 minutes. We can complete it, but I need to see whether we can do it or not, because I think it will be too much of the information today itself. Let me see if we can just complete it. Okay, I'll cover, let's do one thing. I'll complete the 6th component. Okay. I'll take your questions and we're going to wind up. I don't want to go with the deployment. Reason being, because you'll get confused. I don't want to overflow with the information today itself. I understand this is a very extensive topic. It's a 4-hour topic. We can't complete that in 3 hours, because the thing is that generally in a weekend batch, we take 4 hours to complete this single topic. So in the 3 hours, we can't do that. And I don't want to rush and just complete everything today itself. Okay, because it's very important that we don't just rush through the topics and just to make sure, we just want to make sure that we understand every concept in detail. Because if you understand the theory, then you can easily understand the deployment process. Okay, so then the last thing we'll discuss is the gateways, and after that, tomorrow we'll start with the configuration part. Not right now. Okay. The next thing that we discuss is the VPG. That stands for, let me just write on once again. This is the VPG, that stands for Virtual Private Gateway. Okay. And CG, that stands for Customer Gateway. Now, what's the difference? What's the difference between these 2 different entities? Or what are they? See, the thing is that it helps to create or establish a hybrid infrastructure in such a way that, let's imagine this is my VPC. Okay. And this is my branch office / my data center. Okay. Now I want to connect them using VPN. So what I do is that I place a virtual router that's called the VPG, Virtual Private Gateway, and I place a customer gateway, CG, at the border of my branch office, and I connect or establish a VPN connection. Now, VPN connection is a tunnel that you create through the internet. So this is the encrypted channel. This is the encrypted channel. So you establish a VPN connection through these two gateways so that the data or the traffic that flows to and fro between these two different gateways is entirely encrypted. It's entirely encrypted. So this VPN connection is being created through the internet. It's a tunnel. It's a tunnel which is encrypted. Okay. So these are two gateways that we use in that case. Today, we're going to apply the entire theory that we discussed in the previous session. So right now, I discuss everything in terms of the demonstration, and we'll just understand that how exactly you can just create and configure a custom VPC or a non-default VPC. Now, one thing that's very important is that you have to stay focused, because this entire conversation will be complete demo, or it will be complete hands-on. So the thing is that you have to ensure that you just keep your attention or the focus on the concept that I share with you. I'll take your questions once I'm through with the entire deployment process. So once I'm through with the entire configuration, then I will start taking your questions one by one and ensure that we understand every concept in detail. Because the thing is that even if we haven't understood the theory, it's of no use unless and until if we understand the exact the application or the practical demonstration of those different topics that we discussed. So today we'll just amalgamate everything. We'll just discuss everything one by one, and then we will start with the configuration. Basically, we'll just do the configuration. Now, the very first thing is that I just discussed with you the blueprint first. The blueprint has to be discussed. The blueprint means that the network diagram that we will be using to perform the deployment. Now, I've shared with you the documents that are relevant to this topic. That's a VPC. And through these documents, you can also just do your self-study and understand the concepts in detail. Okay, you can very well do that. So you just allow me a few seconds over here. I just need to just pull out or get the exact blueprint for you, so that before we can start with the demonstration, we can just make sure that we can understand the exact architecture. That's the main intent. Okay. So this is the network diagram that I was talking about. This is the one that we'll be using as a blueprint. This will be used as a blueprint. So I will just export it to my Notability app so that I can just sketch it for you and help understand that what things we will deploy and what should be the process that we will follow. So you just allow me a second over here. Okay, so why did I pick this diagram? Because this is the basics, or this is the basic fundamental concept that you will see. The thing is that if you just go in a business environment, the concepts are same. There's no difference in the concepts that you will see over here, and you apply in the business environment. I think I have stated this the same thing multiple times before. The concept that you will see over here and the concept that you will apply in the business environment, or you will use over there, there's no difference. The basic fundamentals are same. It is just that the scope is bigger in a business environment. Right now, I'm showing you a VPC with two subnets. Maybe you may create a VPC with 20 subnets, 50 subnets. Okay, so the scope is bigger. That's the only difference. The basic essence, the basic fundamentals are same. There's no difference. The reason being, the AWS management console that you get in a free tier account is same as you get in a business account. So in a nutshell, there's no difference in the options and the features you get on both the accounts. Okay, so I'll go straight away for at least an hour, explain you this concept, and also I'll also make use of a checklist. I've shared with you via the link, and also I just pull I just extract the checklist, the Evernote checklist that we'll be using to just follow the steps, because I think that there are 13 to 14 different steps that we have to follow. So if I just open my checklist right now, let me just drag and drop that over here. So this is the checklist that we'll follow to just create our first non-default or the custom VPC. Fine. This is a checklist that we'll be using. Fine. Now what I'll do is that let me just first of all explain you this diagram, because based upon that we'll just deploy everything. So the intent of this session is that we understand that how you just structure or construct the entire custom alias, your non-default or the regular VPC. These are same things. Custom, regular or non-default VPC is the same thing. Basically, it's a VPC that you manufacture on your own. You customize it and you have the ability to create multiple layers of resources. For example, you can keep your public-based resources in the public subnet, for example, the front-end web servers. On the other hand, you can keep your back-end servers or the databases. So you can keep your back-end servers or the databases in the private subnet. Okay, so you get more flexibility, more customizations with the custom VPC. So the custom VPC has this benefit over the default VPC, because in the default VPC everything is public in nature. Every subnet is public and every instance automatically gets the public IP. So in that case we don't get the customizations and it is less secure as compared to this custom VPC. Fine. So let's get started. Now over here, if you see this VPC has a CIDR range. Now, what is CIDR? I'll start with this thing. CIDR stands for classless inter domain routing. Classless inter-domain routing. So the thing is that you assign a CIDR block. So it's named as CIDR block to our VPC and the subnets. Now, if I just name it in a very simple way, it is the IP address block or IP block or IP address range. IP address range. It's a complete block of IP addresses. Okay, so CIDR stands for classless inter-domain routing, and the simplistic way to express it is that it's a IP block. It's a IP address block. It's a complete range of IP addresses. Fine, that's how you define it. Now the thing is that if you just look into this VPC, if you look into this VPC right now, you will see one thing that I've just assigned it a CIDR range of 10.0.0.0.0/16. Let me just go back over here once again. Let me just remove these things. So we have this 10.0.0.0/16, 10.0.0.0.0/16. What is this /16? What do you mean by that? So there's a complete concept of subnetting and IPv4 addresses that work behind the scenes. I'm gonna just give you a very brief overview. I will not go in details because it's a part of networking. And also, just for your level of understanding, I just will explain you. You don't have to deep dive into these concepts, but just try to understand these concepts right now. See, the thing is, an IPv4 address, if you take an IPv4 address, it's of 32 bits. So an IPv4 address is of 32 bits. How does of 32 bits? For example, I take an IPv4 address as 10.0.0.0. Fine. So an IPv4 address consists of 4 octets. Octet. So for example, this is my first octet. This is my second octet, third octet, and fourth octet. So each octet consists of 8 bits. So if you sum up all these bits, 8 plus 8 plus 8 plus 8, it comes to 32 bits. So that's why we say that an IPv4 address is of 32 bits. Okay. Now the thing is that if I just take my VPC, so let me just sketch over here. We have this VPC of the CIDR range 10.0.0.0/16. This means the first 16 bits we are using for networking or to define the networks, and the leftover bits will be used for hosting or to define the hosts. Okay, so the first 16 bits for networks and the leftover bits for hosts. That's what the /16 means over here. Now this is the CIDR range that we will be using for the VPC. Now the question raises that why did I choose the 10.IP address? Because remember, we have to choose any of the private IP address ranges starting from 10 or 172 or 192.168. We have to choose any of the private IP address schemes to structure my VPC. This is very important for you to understand. Well, let's do one thing. Let's carve out the subnets out of it. So how do you just extract the subnets? So basically what you do is that in the VPC, you add on 8 more bits. So 16 plus 8, 24. Okay. So now I would say that let's segregate it further. Let's add 8 more bits to the networks and let's create the subnets. So I start with my subnets like this. I start from 10.0.0.0/24. Then 10.0.1.0/24. Then 10.0.2.0/24. 10.0.3.0/24. It will go up to 10.0.255.0/24. So if you see over here, this means if I, for example, if I pick this subnet 10.0.2.0/24, I'm saying the first 24 bits will be used to define my network and the leftover 8 bits will be used to specify my hosts. Okay. So from 0.0 to /24 to 255.0/24, this means that you can carve out 256 subnets out of this. From the VPC of /16, you can just extract or you can just manufacture up to 256 subnets. You can very well do it. Fine, you can very well do it. So the next thing that comes into the picture is that how exactly you specify the instances, because remember, in the VPC, what you have? Subnets. In the subnets, what you have? Instances. Right? Now, the next thing that we'll do is that we just add on 8 more bits to make it /32, and these /32 IP addresses will be allocated to my instances. Let's do one thing. Let's pick this subnet. So in this subnet, how do I add on 8 more bits and specify /32 IP addresses or IPv4 addresses for my instances? How would I do that? So in this case, what I will do, I start from 10.0.2.0/32, 10.0.2.1/32, then 10.0.2.2/32, 10.0.2.3/32. It will go up to 10.0.2.255/32. So I'm taking all the bits to define my network. Okay, and the thing is that each IP address would be allocated to my EC2 instance. Fine. Now, if you see over here, just give me 1 second over here. If you see over here, the number of IP addresses we have is starting from 2.0 up to 2.255. So from 0 to 255, how many IP addresses we have? 256. So in each subnet, I get 256 IPs, which comes out to be 65,536 IP addresses. These many resources I can launch in this /16 VPC. See, the thing is that you don't have to do such math. You don't have to do such calculations. On the internet, you can very well Google the subnet calculators that you can just use and just calculate the subnets and the IP addresses very easily. You don't have to look into that. Why I just showed you, because just to give you a small idea that how exactly the subnetting is being done. Okay, so you don't have to stress too much upon it, because at the end you will not do any kind of subnetting. You don't have to do that. The main thing that you have to do is that you have to structure the VPC. That's the main thing that you have to perform. Okay. Now the next thing that we'll just do is I just explain you this entire diagram now. So I explain you this diagram so that you understand the concepts. So in this diagram, what we'll do is, this is my VPC with the IP address range 10.0.0.0.0/16, and it consists of 2 different subnets. One is a public subnet with the range 10.0.1.0/24. There's a public subnet which is allocated to one of the availability zones. On the other hand, down below, we have the private subnet with the range 10.0.2.0/24. It's being allocated to the availability zone P. You can allocate to the same zone or different zone. It's up to you. Fine. Now the thing is, over here, what we have to do, in the public subnet, we keep our web servers, which should be exposed to the internet, So we keep them in the public subnet. And there's one thing that you have to recall, because we discussed that in a previous session. That is, we have to allocate the elastic IPs to every server or the component that we launch in the confinement of the public subnet. Why? See, the thing is that, first of all, in the custom VPC, the concept of public IPs generally it doesn't exist. If you're using auto-scaling, that's fine. So you have to depend upon the usage of the elastic IPs in order to expose your web servers that you have launched in the public subnet. So the first thing that you have to allocate, you have to ensure that you allocate is that you allocate the elastic IP to every EC2 instance or every server or every resource that you deploy in the confinement of the public subnet. It's very, very important that you do this. And the second thing is that you have to attach the VPC. You have to attach the Internet Gateway to the VPC. You have to attach it. And once you attach the Internet Gateway to the VPC, the next thing that you have to do is you have to associate it using the route table. You have to associate it to the subnet using the concept of route table. You have to do it. So what you will do is you have to fulfill both the prerequisites. You have to ensure that you allocate Internet Gateway to the subnet to make it a public subnet. So that subnet should consist of the instance with the elastic IP attached to it. If you miss any one of these two different conditions, you cannot make your instance exposed to the public. It's very, very important that you go about doing it. If you miss any one of these two different conditions, you cannot make your instances exposed to the internet. It's very, very important that you fulfill both these two different conditions. They have to be fulfilled. Fine. Now, the thing is that this is what we have to deploy for the public subnet. What about the private subnet? See, private subnet is the one that consists of your backend servers, especially your databases. So the thing is that this portion should be completely isolated or cut off from the internet. There should be no access to the internet whatsoever. So this portion should be completely isolated or it should be cut off from the internet. Now, how do we achieve that access, or I would say how do we achieve that isolation? This is very important. How do we achieve that isolation? The answer is simple. How do I have this private subnet cut off from the internet? The things that are there for the public subnet would be missing in the private subnet. Simple answer. You don't allocate the elastic IPs / public IPs to any of the resources. Of course, public IPs are no longer the part of the default VPC. So in that case, you don't allocate any of the elastic IPs to any of the databases or the servers that you deploy in the private subnet. And also, you don't allocate the Internet Gateway to the subnet. So the things that are very, very important for the public subnet should be missing in the private subnet. That's the entire crux of the essence of the VPC. That's how you differentiate between the public subnet and the private subnet. That makes a big difference. Fine. Over here, let's do one thing. Let's rub it off and let's focus upon the NAT now. And also this will help you to just clarify your doubts if you have any in case you want to understand the NAT functionality. So the thing is, we have discussed the public subnet, we discussed the private subnet. But there's one thing that's there, which is uncommon, which is optional. That is, we have this thing called NAT. NAT stands for Network Address Translation. Network Address Translation. The purpose of having this device is, so we discussed that there are two types of NAT devices. We have NAT gateways and we have the NAT instances. NAT gateways and the NAT instances. The purpose of the NAT gateway is, or the NAT instance is, it allows the databases or the backend servers in the private subnet to download the patches without revealing their private IPs. So for example, I just take a very small example. This NAT instance has an elastic IP of, for example, 13.52.76.91. Okay. And there is a MySQL database with a private IP of 10.0.2.4/32. This MySQL database has to download some updates. It will contact the NAT gateway, and how it will be determined using the route table. It will be determined using the route table or the route table. Now, what will happen next would be that the NAT device will just forward this request to the internet. In that process, the magic happens. The magic is, or the main thing is, that the NAT will change the source IP to its own elastic IP, saying, I am making the request. See, basically, logically, this should be the source IP. The MySQL DB instance private IP should be the source IP because it is making the request. The source request is coming from this database. So this private IP 10.0.2.4/32 should be the source IP. But as soon as the traffic flows through the NAT gateway, it intentionally changes the source IP to its own elastic IP. So if there's a hacker sitting over here, he or she will not be able to comprehend or get to know the exact private IP address scheme of your databases running behind the scenes. And also, no one can initiate a fresh request to the NAT gateway. It's not designed for that. Now, the thing is that once the response traffic comes for that request from the particular server or website, it hits the NAT gateway, and the NAT gateway will change the target IP to the exact private IP address of the MySQL database so that the patches can be downloaded by the exact MySQL database. That's a whole and sole purpose of using the NAT gateway, so that the databases or any of the servers running in the private subnet can download the patches without revealing their private IPs or compromising their security. Fine. This is the purpose of the NAT device. And we have discussed two different types of NAT devices. That was the NAT gateway and that was the NAT instance. Okay. So let's start with the deployment process. You just pay attention to every concept that I'll show you right now. And after I'm done, then I'll start taking your questions one by one. Fine. So let's get started. Okay, let me do one thing first. Let me just rub off the entire stuff so that we can use the same blueprint same diagram again once we are through some of the steps, because I'll be referring to this diagram in between the process of configuration. So let me just drag it to the next other screen, and here we are on the main page. That's on the AWS Management Console. See, first of all, the VPC is a region-specific resource. You cannot have the VPC scattered or span across multiple regions. It's not designed for that. So I choose Mumbai over here, and I just search for the VPC under the networking and content delivery. I just go to the VPC right now, and this opens my VPC dashboard. Now, in every region, you can have up to 5 VPCs, including one default. So you can have one default and 4 non-default. Now, I can just go to this thing, launch VPC wizard, and I can just choose any of the templates and hit select. For example, I go with this one, VPC with public and private subnets, hit select. I can just choose options and click on create VPC. It will take me only a minute to create a VPC in front of you, but I will not do that. I will just go a tougher way. Why I'm going a tougher way? Because I can just easily just show you the deployment in just a minute, maximum a minute. But I'm going a tougher way. I'm spending 45 minutes to ensure that you understand each and every component from scratch. Okay, you can easily choose the options right here. Click create VPC, and you don't have to put too much of your thought process into this. But I want to hone your concepts so that once you start building the architectures, you understand the basic concepts. So I click on cancel and exit, and I click on your VPCs on the left hand side. So this is my default VPC in Mumbai. Now, as we have mentioned, or as I mentioned in the previous session, you should not manipulate or delete the default VPC. If you delete the default VPC, you have to open a ticket with support to get it restored. So don't change or delete your default VPC. I click on create VPC on the top, and I get this wizard to create a custom VPC. The very first thing is that I have to just assign a name to it. So name it as custom underscore VPC. Then it says that you assign the IPv4 CIDR block. So in my case, it is 10.0.0.0/16. This is the CIDR block based upon this blueprint. The blueprint that we're using. Let me just drag and drop over here once again. So based upon this blueprint that we're using, you can see over here on the left hand side where my cursor is. This is the CIDR range that we'll be using. And we will not use IPv6. We go with the IPv4. Now, the next thing that we have to choose is the tenancy. What is this tenancy, by the way? If you remember, we discussed it somewhere. Okay, we discussed the tenancy in one of the services that we discussed in the previous week. Let me help you to recall that. If I just go to the EC2, we discussed the 2 types of tenancies. One is the shared tenancy, and the other one is the dedicated. So today, I want to launch an instance. So I click on launch instance right now. I choose my EMI. I choose my instance type. So on the third step, where we configure the instance details, on the configure instance details page, there are 2 types of tenancies that I can choose from. Shared, this means that I have the privilege to run my instance on a shared piece of hardware. So my instance would be running on the same physical host that would be shared among other organizations, and individuals. This type of tenancy is free of cost. But if I go with a dedicated host or dedicated, it's the same thing. The only difference is that the host gives you more transparency. So if I go with the dedicated tenancy, I pay for the entire physical host on the on-demand basis, I would say for each hour, or I can just reserve a physical host for 1 year or 3-year contract. So in that case, I have the privilege to run my own instances on my own physical host. I don't allow any other individual to run the instances on the same physical host. This is mainly useful if you have some strict legal requirements, some compliance requirements, or maybe, for example, some of the databases like Oracle Enterprise Edition database. So the Oracle Enterprise Edition database can only be run on the dedicated physical host. So in few exceptions, you may go with the dedicated tenancy. Now, you may be wondering how this is relevant to the VPC. It doesn't make any sense. It will make the sense if I just give you the exact understanding right now, or the exact answer, that how the VPC tenancy relates to the instance tenancy. The answer is, whenever you create a VPC and you choose the tenancy as default, then any instance that you launch in the same VPC, because you have to choose that VPC over here, you have the privilege to switch between shared or dedicated, because this tenancy is at the hardware level. It's at the hardware level. So at the hardware level, you choose shared or dedicated. You have the complete privilege. But at the VPC level, if you choose the tenancy as dedicated, then what happens? Every instance would automatically be launched on the dedicated physical server. For example, I choose shared. I launch a shared tenancy instance in the dedicated tenancy VPC. Even in that case, if I choose this option at the instance level, still the instance would be launched on the dedicated physical server. So in a nutshell, if you choose the tenancy as dedicated at the VPC level, no matter what you choose at the instance level, every instance will be launched on a dedicated physical host. So to be on the safer side, you choose the tenancy as default. So how this will help you? So you can decide later on at the instance level whether you have to launch it on a shared physical server or on a dedicated physical server. You can decide it later on. The problem is, if you choose dedicated, first of all, you have to pay extra charges for the dedicated tenancy. And that the problem is that this option can't be changed afterwards. After you create the VPC, this option cannot be rolled back, cannot be removed or changed. So to be on safer side, you choose the default tenancy. Okay. Now I click create, and this creates my VPC. I click close, and this creates my custom VPC. Fine. Now the thing is that if I just bring in this blueprint, the next thing that we have to just create are the two subnets. One is a public subnet with the range 10.0.1.0/24. I assign to one of the AZs, and I create another subnet that's a private subnet with the range 10.0.0.2.0/24 and assign it to one of the AZs. I can assign it to the same AZ or different one. It doesn't make a big difference over here because it's a lab environment we are going through. Okay, and in the meantime, let me just drag and drop the checklist. So we have performed the first step. We have created a VPC with CIDR 10.0.0.0.0/16, and we have chosen the tenancy as default. Now we just carve out two different subnets, one public, another private. Let's do that. I click on the subnets on the left hand side of this page, and these are the subnets of my default VPC. So I click on create subnet at the top, and in the name tag I just name it as my public. Let me just name it once again. This is my public underscore subnet. Let's type it once again. And the VPC range, or the VPC would be the custom VPC. Availability zone, I choose AP South 1A, and the CIDR block would be 10.0.1.0/24. Click create. Similarly, I create another subnet. So I just click on create subnet. Just type in private underscore subnet, and the VPC will be the custom. VPC will be the custom VPC. I choose the availability zone AP South 1B, and the CIDR block should be 10.0.2.0/24. Fine. I just go ahead and click on create. Done. I click close, and that's been done. So we have performed the second step. Now, in the third step, what we're going to do is that if I just drag and drop the same blueprint, the next thing that I am supposed to do is that I just create this internet gateway and attach it to the VPC. I'll just create an internet gateway and attach it to my VPC. What I will do is I just go back on this VPC dashboard on the left hand side where we have this navigation pane. I just click on internet gateways. Now this internet gateway is being attached to my which VPC? My default VPC. I click on create internet gateway at the top left hand corner, and you can see that the description over here. An internet gateway is a virtual router that connects a VPC to the internet. So let's name it as my underscore IGW and click create. Done. This has been created. I click close. So this my underscore IGW internet gateway is being created, but right now it is detached. It is detached. So I choose it, go to actions, and click on attach to VPC. So I choose my custom VPC. Now you can see the description on the top. Attach an internet gateway to a VPC to enable communication with internet. I click attach, and this attaches my internet gateway. So if I just open the checklist, we have created the internet gateway, and this is being attached to the VPC. Done. Fine. Now, so we have performed these three steps over here. The next thing that we have to understand is that even though this internet gateway that we have just associated or attached to the VPC is of no use. Why? Because even though you attach the internet gateway to any of the VPCs, it has to be made available to the subnet. Okay, so if you just create and attach an internet gateway to any of the VPC, it's only the half configuration that you have done. It has to be associated to any of the subnet, that you have to make it as a public subnet. So what you will do is that you have to associate this internet gateway to the subnet using the concept of route table. Now, if you remember, we discussed about the route table. Route table consists of the routes. It's like a GPS. It helps the resources to understand and comprehend that how exactly they will communicate internally or externally, or it allows the traffic to flow in and out of the VPC. Okay, so the main purpose over here is that how these web servers will get to know that if they have to reach the internet, the network traffic should go to and fro through the internet gateway. Because the thing is that, let's understand this important fact. These servers are dumb terminals. These are dumb. They don't have any intelligence on their own. So you have to just configure the entire stuff in such a way that if these web servers, they want to talk to the internet or want to be accessed by the internet, we have to just help them understand that the entire communication should be initiated or processed through the internet gateway. And that's been determined by the route table that we will just create right now and allocate it to the public subnet right now. Now, the thing is, let's imagine you don't go with any new route table. What happens is, as soon as you create a VPC and the subnets, it creates a default route table by itself. Let me show you. If I just go over here, this is a default route table that's being allocated to both the subnets. So this is my default route table. You can see down below that this is being allocated to I would say to both the subnets of my VPC. Okay, so the main thing I want to stress upon is that if you don't configure and allocate the custom route table to any of the subnets, by default they'll pick the default one. And what you have in the default route table, you simply check its routes. It will consist of the CIDR range of the VPC and the target as local. What do you mean by that? This means that it allows the local communication between the resources in the VPC. This means, let me just help you explain this thing, or help you understand this thing. The resources can talk to each other internally because of the local route that's being present everywhere in every route table. So regardless of the subnets, the instances can talk to each other internally in the same VPC that's being facilitated by the local route that's been present in every route table. Whether you go with the default or you just create your own custom route table, it's there by default. Now, the thing is, as per the best practice, don't change the default settings. If you want to have a custom one, it's better you just create a custom route table. So I go to my subnets. I want to just apply a new route table because it's both the subnets are picking the same default route table. I want to create a new one for the public subnet right now. And after a few steps, we'll create another route table for the private subnet. So I go to the route tables on the left hand side and click on create route table on the top. And you can see the exact definition over here. A route table specifies how packets are being forwarded between the subnets within your VPC, the internet, and your VPN connection. So it determines the inbound, or I would say internal and external traffic flow. So I just name it as my public route table because that would be assigned to that would be allocated to my public subnet. And I just create it for the custom VPC. Click create. Done. I go to the route table and specify the routes. Now, any route table you pick the default or the custom one, will automatically have the local route. You can't change it. You cannot delete it. I click on edit routes over here, add a route, and I specify the destination, that is 0.0.0.0/0. This means any IP on the internet. And the target should be the Internet Gateway, which is the one that we have just created and attached to the VPC. Click Save Routes. Click Close. So I'm saying that this route table will consist of the route, two routes. One is the local route, which facilitates the internal communication, and the other route that allows the access to the internet, through the Internet Gateway. Now, I go to Subnet Associations, click Edit, and assign this route table to the public subnet, and click Save. If I go to the subnets on the left-hand side, choose a public subnet, go to the route table, you will see that it automatically picks the custom one. So by default, or I would say, you can only assign one route table to one subnet, but the same route table can be assigned to multiple subnets. I can just go to my private subnet, click edit, and I can just change the default route table to the custom one that I've just created, and click save. But I will not do that. So the main thing I want to stress upon is that you can allocate one route table only to one subnet, but the same route table can be allocated to multiple subnets of the same VPC. Okay, so I've allocated the custom route table to the public subnet. Fine. So let me just drag and drop that checklist over here. So we have performed this thing, these two steps. We have created the route table and we have associated it to the subnet to make it a public subnet. So if you assign the route table, which consists of the route towards the internet through the Internet Gateway, you assign it to the subnet, it becomes a public subnet in the real sense. Now, I'll do one thing. I have two subnets right now. I'll launch one instance each in each of these subnets. So I go to services right now. Okay, I just go to my instance dashboard and click on launch instance. This time I'll pick Ubuntu Server 18.04 as my AMI that I'll be using for both instances in my VPC. Same AMI will be used for the instance in the public subnet, and same AMI will be used to launch the instance in the private subnet. So I click on select over here. I go with the same t2.micro as my instance type. Click on configure instance details. I choose my custom VPC and I choose my public subnet. Okay. I click on next add storage, next add tags. I click on add tag and just name it as my public instance, because this has been launched in my public subnet. So it will be easy for me to differentiate. Just name it once again. This is my public _ instance. I click on next configure security groups. So I just create a new one. Let's name it as VPC Practical SG, and I just copy and paste same in the description. Now, as of now, I open all the HTTP, HTTPS, and SSH ports. Just for this example, click on Review and Launch. I can choose any of the existing key pairs if I want. So let me see if I have a copy of any one of these keys right now. Let me see if I can just search for it, or I can just go ahead and I think I have this one. Let me just this one, ASG demo. If I don't have that, I can simply create a different one. So let's do one thing. Let's create a new one. Okay. So I just click on create new key pair, name it as VPC demo-kp. That's it. I click on download key pair. It downloads the private key. I'm just going to use it afterwards. I click on launch instances right now in front of you. So I just launched an instance in the public subnet of my VPC. Then I click on launch instance once again. I choose the same Ubuntu server 18.04 AMI. Click select. I go with the same t2.micro as my instance type. Click on next configure instance details. I choose my custom VPC and I choose my private subnet this time. I click on next add storage, next add tags. So in a tag, let's name it as my private underscore instance. So this is a tag value I was assigned to it. Click on next configure security group. I just pick the same one that I've allocated to my public instance. I click on review and launch, choose the same key pair. Let me just do that. And just click on launch instances. And that's been done. Fine. So as of now, I've launched two instances, one in the public, another in the private subnet. So let me check mark this option, this step that we have performed. Now, the thing is, I have launched this public instance. Let's focus on this public instance. This public instance is been launched in the public subnet that has access to the internet gateway. Now, can I initiate the SSH access to it? Because I'll be using the internet as a medium. Can I access it via the internet? So this public instance is launched in the public subnet. Technically, it should be fully publicly accessible. But the problem is it has no public IP. You have to fulfill both the prerequisites. You have to launch an instance in the public subnet and also the public IP or the elastic IP. Elastic IP should be allocated to it. Now we don't have the concept of the elastic IPs. The public IPs in the custom VPC, unless you're using the if you're using the auto scaling, that's a different story. But right now we are not using any auto scaling. So in that case, if you're not using it, we have to rely upon the usage of the elastic IPs. Because remember one thing, the private IPs are not reachable over the internet. For example, if I just open my terminal right now in front of you, and let's do one thing. Let me just go to my desktop and just try to, okay, let's just try to change the access rights of this private key. Let's go to downloads. So Now, let's try to connect to it using its private IP. So technically, it should be connected. It should connect because it's launched in a public subnet. But one thing we have to remember, the private instances, because it already has the private IP. I'm sorry, the private IPs are not. They can't be accessed over the internet. So if I just copy and paste the private IP over here, you will see that eventually it will just time out. It will not do anything. So the next thing I should be doing would be I should allocate or associate the elastic IP to it. For that, I go to the elastic IPs on the left hand side of my navigation pane. Let's go there and click on allocate new address. Click allocate. Click close. I choose my elastic IP, go to actions and click on associate address. I choose my public instance. I choose the private IP of the public instance and click associate. Click close. I go back to my instance dashboard, choose my public instance and copy its elastic IP, which is now equal to its public one. So I hit Control Z, rerun the same command, but this time I just mention the elastic IP. And here we go. We got the prompt to connect. So I'm connected to the instance running in the public subnet. Now the next question is, can I install the updates to it? Let's try it out. I run the command sudo apt get update. I hit enter. Invalid timed operation get. I think it's sudo apt. Okay, there's a hyphen in between. Sorry about that. And you can see that I'm able to download the patches or the updates to this instance, and this entire traffic is coming through the internet gateway. So I can SSH to this instance using internet as a medium. I can download the updates. So everything is working perfect. So this instance is fully publicly accessible. It's completely exposed to the internet. Fine. It's working perfectly for me as of now. So if I just go back to my checklist, the list, I have performed these two steps. Fine. So we have deployed everything for the public subnet that we were supposed to deploy. We have deployed everything for the public subnet. So everything is being configured and deployed for the public subnet. Now, what about the private subnet? For the private subnet, for the internet access, I have to deploy this NAT gateway. But first of all, I need to just SSH to the instance in the private subnet, because the thing is that after I deploy the NAT gateway, how can I test whether I'm able to download the patches to any one of these instances that I may launch in the private subnet? So I need to SSH into one of the instances. But how can I do that? This is completely cut off. It's completely isolated. How can I access it using internet? The workaround is that so what I can do is, as an administrator, I can SSH to one of the instances in the public subnet, and internally I can initiate another SSH connection to one of the instances in the private subnet. Now, how this is possible? The local route. The local route will allow me the internal access between different instances in the same VPC. Okay, so I can SSH to one of the instances in the public subnet, and then I can initiate the another SSH connection running in the private subnet. Plain and simple concept. Now, the question really is how it can be done, because you'll be using the same PEM key. So the thing is that I'll be using the same PEM key or /.ppk key and the same PuTTY or terminal session. See, there's a complete, I would say there's a complete concept behind it. I've shared the VPC documents with you in the resources section or to the Google Drive. If you open that document, it consists of if you open that folder, I would say, it consists of a document which is SSH using the same key. Can you see that? If you open this document right now, I'll show you right now in front of you. It consists of the entire process for you to initiate this type of connection by uploading the private key using the same PuTTY or the terminal session. So for the people who are running OS X, but now we just name it as Mac OS, this is how you have to perform that on the terminal. So the same steps I'll show you because I'm using Mac OS. So I'll be using the terminal. For the people who are using Windows machine and they're using PuTTY to connect, you have to download an additional software that's called the Pagient. Pagient software you have to download. I've included a link. This is free of cost. You can download this Pagient software to which you will upload your private key. And then you have to just check mark one option which says allow agent forwarding on PuTTY. Using the same PuTTY session, you connect to the instance in the public subnet and internally to the instance in the private subnet. Okay. Now, since I'm using Mac OS, I'll use my terminal, the same terminal session. So let me just close this one out and open a new one. So let me just open a new window. Okay. So what I will do is I will just go to my desktop where my key is being saved, and I upload my key by running this command. Of course, on the Windows, you have to download the Pagient software to perform the same operation. So let's type in SSH add -k VPC demo.pem. Okay. I'm sorry. I think I need to just correct it. VPC demo-kp.pem. I've uploaded the key. Then once I upload the key, I just run the command ssh-a, then Ubuntu @ then I just copy and paste the elastic IP of the instance in the public subnet. Done. I'm connected. Now internally, I'll connect to the instance in the private subnet on the same terminal session. SSH, username Ubuntu, @. Now I'll use the private IP address of the instance in the private subnet. You may ask this question, why using private IP? Because right now I'm not using internet. I'm connecting internally. I'm not going over the internet now. So I just copy the private IP and paste it. Get the prompt, and I'm connected. Simple. Fine. So we connected to the instance in the public subnet, and internally we connected to the instance in the private subnet. So we have performed this step. Now the purpose of this connection is that now I can just show you the deployment of the NAT. NAT has to be deployed. It's extremely important that you go ahead and deploy the NAT. So the NAT has to be deployed in the public subnet. So for that, I go to my VPC dashboard or VPC management console and click on NAT gateways on the left hand side. Click on create NAT gateway. I choose my public subnet. Now, if you have the Elastic IP already, just create it, just assign it, or just click on create new EIP. It will allocate this Elastic IP to the NAT gateway that we are launching in the public subnet. We click on create NAT gateway, click close. Now, since we have created the NAT gateway, it's of no use. Why it is of no use? Because if I look into this blueprint or this architecture diagram, how these servers or the databases will understand that if they have to reach the internet, they have to communicate with the NAT gateway. The answer is that I have to just create a new root table and assign it to the private subnet. So what I will do, I just go back to my root tables, click create root table, and just name it as private underscore root underscore table. I choose my custom VPC, click create, click close. I choose my private root table, go to routes, click edit. Now it already has the local route. I add a route, specify the internet IP, that is 0.0.0.0.0/0. And what should be the target in this case now? The NAT gateway. So I'm saying that what I want to specify is that the entire internet traffic should go through the NAT gateway. Click save routes, click close. Now I choose this private root table, go to subnet associations, hit edit, and choose my private subnet in this case. Click save. If I go to the subnets on the left hand side, choose my private subnet, just go to the route table, you can see that it's being allocated. So this route table has two routes. One is the local route, and the other is the access to the internet through the NAT device. And this root table is being allocated to my private subnet. Now, so we have performed this thing, these two different steps, and we have associated the route table. Now in the last step, we just try to install the updates to it. Let's do that. Let's go back to this terminal, and let's try to install the updates, because right now we are logged into the instance in the private subnet. Run the command sudo apt get, just correct it, sudo apt get update, and here we go. This entire traffic is being managed by the NAT gateway behind the scenes. This completes the entire process of the VPC deployment. Now, you guys can just perform all the operations. I've shared the resources with you. You can just check out these resources in the document. You can just check the blueprint as well as the document that I'll be attaching. I'll be just giving to you. You already have I already uploaded all these documents to the Google Drive, and the link is being mentioned. So you can use the same steps with the screenshots and perform the steps on your own. The only difference is that the steps that I've shown you, it includes the NAT gateway deployment, and this shows you the NAT instance deployment. That's the only difference. Otherwise, all the steps are same. Okay. And one thing, once you perform this operation, it's extremely important that you clean up everything. See, VPC as the service is free of cost. There's no charge for it. You don't have to pay even a single penny for it. It's absolutely free. The only thing, the only time that you have to pay for it, is the NAT gateway. So of course, the instances that you launch into that, it's being charged separately. Instances are separate. VPC as a service is free. You just have to pay for the NAT gateway. I think it's almost 30 cents per hour. Okay. Now, once you perform this operation, you have to make sure that you delete the NAT gateway, release all the elastic IPs, because the problem is if you delete the NAT gateway, its elastic IP is not being released automatically. You have to separately go to the elastic IPs on your instance dashboard and release the elastic IP of the NAT gateway. So this is the only component that's for which you have to pay few cents per hour. Otherwise, the VPC as a service is free of cost. And of course, the instances that you run in a free tier account, you get some hours, 750 for Linux, 750 for Windows each month. Okay, so after you're done, you have to follow the cleanup process so that you don't get charged for using the NAT gateway. That being said, this completes the conversation on building a first non-default VPC. So thank you so very much for your time and patience. So the next thing that we discuss is the VPC peering. What is that? VPC peering. So what is this concept and what exactly this is all about? See, the thing is that you may come across a scenario where you have to connect two VPCs together. So that concept is called, let me just write it once again. That is VPC peering. Okay. And this VPC peering, what you do is that you connect two VPCs or multiple VPCs together. Okay. So what you do is that you connect multiple VPCs, okay, together. Okay, and you can establish this connection across the VPCs in separate regions, and also you can establish this connection across separate accounts. So VPC peering is an option for you to connect multiple VPCs together in the same region or separate regions, in the same account or across separate accounts. Okay. Now the question really is that what are the use cases? What are the use cases of using this service? What's the use case? So the use case is, for example, there's in your organization, you have multiple business units or the departments. So in your organization, you have several business units or the teams or departments. So for example, this is my department. This is my VPC for finance. Okay. This is my VPC for management. This is my VPC for HR. Okay. Now it's the same concept like we use VLANs in the organization. So if we have multiple VPCs that belong to separate teams in my organization, now you connect them together using this concept called VPC peering. Okay, use this concept so that you connect these VPCs together, and these different VPCs can share some of the resources and services. So you can make use of this service in your organization. That's a VPC peering. Now, the next use case can be, it can happen across separate accounts. For example, NASA has a VPC on Amazon Web Services. On the other hand, SpaceX, which is being owned by Elon Musk, so they're working on a single assignment or a research program. So these are two different organizations. They have their own VPCs that are located in their respective accounts. You can just connect them together using the same concept called VPC peering. You can just peer these two VPCs together. You can just connect them. It's called the VPC peering. So you just connect two VPCs together, even though they belong to separate accounts. Now, it has certain limitations. The limitations are, what are those limitations? First of all, the first limitation is, okay, this is the only limitation. There's only one limitation, that it doesn't entertain, so I would say no overlapping CIDR blocks. So the two VPCs, they should not have the same CIDR ranges. There should be no overlapping. They should have different schemes, different blocks, different subnetting. So no two different IP addresses should be same. Okay? That's the only limitation. Fine. Now, the thing is, I'll just take one example and we just follow that example and establish this type of connection. So I have my default VPC. If I show you the IPv4 CIDR of this default VPC, right? So this is my default VPC. Okay, this is my default VPC. The range 172.31.0.0/16. Okay, let me just open this thing. Okay, 172.31.0.0/16. This is my default VPC. On the other hand, this is my non-default VPC, and the range is 10.0.0.0/16. 10.0.0.0/16. Now I want to just connect these two separate or different VPCs using the same concept. So I have to follow a process. The process is that, first of all, you have to pick one VPC as the requester, which will initiate the request to the other VPC. So in my case, my default VPC would be the requester. It will request the connection, and the non-default VPC would be the acceptor. It will accept the request. Okay, so the process is, first of all, the requester will send an invitation. It will invite the acceptor to join. It will just send an invitation to the acceptor to join in. So the default VPC is the requester and the custom VPC is the acceptor. Then in the second step, the acceptor accepts the invitation. to join. And then you have to manipulate route tables. These are the 3 steps that we have to follow to establish this VPC peering connection, VPC peering connection across 2 different VPCs. So how we do that? Let me show you. I just go back to the same management console, and on the left hand side you can see that there are multiple options. We are searching for this option, that is peering connections. I click on create peering connection, and the tag that I would assign to it would be test underscore peering underscore connection. Then I choose the requester, that's the default VPC. Now it will ask you that select the another VPC to peer with, to connect with. So you have to choose the VPC to peer with. So I can choose my account, or I can choose another account. So in that case, if I want to connect to the VPC in another account, I have to choose the account ID. But in my case, it will happen within the same account. Then it will ask you the region. If it's happening across the regions, you have to specify the region over there. You have to specify the region in this case. But this is happening in the same region of Mumbai. Now I choose my acceptor, which is my custom VPC. So I choose my requester, my default VPC, and the acceptor, my custom VPC, in the same region of Mumbai in the same account. Now I just click on create peering connection. And as you can see that it's being done. This is being done. Okay. So once we are through with this, it says a VPC peering connection has been requested. I click OK. Then you can see the status. It says pending acceptance. I choose this connection, go to actions and click on accept request. Click yes, accept. And this is being accepted, and this has become active. Now, the next question releases that if I just open my notes, how the instances on the either side of the VPC will understand that if they have to reach the instance on the other side, they have to connect to that peering connection. That peering connection will be used to connect. So that the peering connection will be used to connect. The thing is that we'll be using the root table for that. So what I will do, I just go to the root tables. First of all, I pick the public root table in my custom VPC. I go to routes, I click edit, add a route, and say that if you want to reach the other side, the default VPC, which has a CID range of 172.31.0.0/16. In that case, the target is my peering connection. My peering connection. This one. Click save. Click close. Similarly, I just go to the private route table. Click edit. I just add a route to the other side of the VPC 172.31.0.0/16, and the target is the same peering connection, same connection. Click save routes. Now I'll manipulate the root table that's being assigned to all my subnets of my default VPC. So if I just go to the subnets and show you the root table, this is a common root table which ends with D4. This is the common root table assigned to all the 3 subnets of my Non-Default VPC. So I just click on this route table, go to the routes, click edit. I want to reach the other side of the VPC. That's my custom VPC. The destination is 10.0.0.0/16. And what should be the target? The same connection, same test underscore peering underscore connection. Click save routes, click close. Done. This completes the entire configuration. So I've connected two VPCs together using this concept. This completes the process of VPC peering. Okay, this completes this process. Now the last thing I'll discuss with you is the configuration of the network access control list. And I've discussed with you in the previous session that what's the purpose of it and why you use it. The only thing I will show you right now is the configuration. If you want to understand the theory, please just you can just check out the previous recorded session, because I've explained you the purpose behind it. So the thing is, how you configure the NACL or the network access control list. So first of all, you have to understand that you have to assign a number to every rule that you create. So the numbers that you have to select should be anywhere between 1 up to 32766. Okay, and the rules that you define, I would say the rules you define, or you need to allocate the rule numbers in ascending order. It should be in increasing order. I'll show you why. It should be in increasing order. Okay. Now, the thing is, let me just go back. And also one more thing. For each and every rule, you either allow or you deny the traffic. So let's go back and let's go with let's go to the access control list under security. We have the network ACLs and the security groups. I go to the network ACLs on the left hand side, and these are the two default ones. See, the thing is that if you don't specify your own network access control list, by default, automatically they'll pick, or the subnets will pick the custom one. I'm sorry, not the custom one, the default one. I repeat myself once again. Let me just come back once again with the same statement. Whenever you just create a VPC and the subnets will automatically pick the default access control list. Let me show you the subnets of the custom VPC. The custom VPC subnets. If I show you the network ACL, this is the default access control list, which ends with 97. And if I show you the private subnet, the same network access control list is being assigned to it. Now, this network access control list allows every traffic to come in and go out, which you don't want in a business environment. So instead of manipulating the default access control list, which your subnets pick automatically, you create a custom one and assign the custom ACLs to each and every subnet of the VPC. Now I'll show you the process. I go to the network ACL on the left hand side and click on create network ACL. You can see the definition. A network ACL is an optional layer of security that acts as a firewall which controls the traffic in and out of a subnet. I assign a tag to it. Let's name it as test underscore NACL. VPC I will choose is the which one? The custom one. Click create. I choose my test NACL. Just go to the inbound. Now the thing is that once you create a new network access control list, it restricts every traffic in and out. Can you see that? It denies every traffic in and out. So you have to formulate and structure the rules one by one. I go to the inbound rules and click on edit inbound rules. I click add rule and start with any random rule number, for example 100. You can choose 1, 2, 3, 4, whatever you want. I go with 100. I choose the HTTP protocol and source is anywhere, and I choose allow. I just add another one. That's 110, 110 for HTTPS from anywhere. I need to allow that. I can choose a rule number 120. I can choose, for example, the POP3 traffic. I want to deny it. I don't want to allow any POP3 traffic. Then I specify the rule numbers 130. Now can you see that? The rule numbers I'm specifying is in the ascending order, increasing order, like 100, then 110, 120, 130, 140. It should be in increasing order. So in the next one, I choose the SSH. Let me choose, for example, let's go with the SSH from a known source, that is 56.89.0.0/24. Okay. Then I add another rule 140 for the same protocol, that's the SSH, and I need to deny that particular range. The range is 13.89.0.0/24. So I want to deny the SSH coming from this IP address range. Save. Okay. Now, how this works for you? This works in such a way that it will process the traffic from top to bottom in increasing order. From top to bottom. So that's why we say that you specify the numbers for each rule in increasing order, because it works from top to bottom. So for example, okay, let's do one thing. Let's go to the outbound. I click edit. I just add rule number 100 for the HTTP traffic to any destination. I need to allow that. Similarly, I add the rule number 110. I need to allow the HTTP to any destination. That's it. Save. Okay. Now I go to the subnet associations, hit edit, and choose my public subnet and assign to it. Okay. This is being assigned to my public subnet. Now, let's imagine the traffic approaches this subnet. That's my public subnet, because if I go to my public subnet, show you the network ACL, this is the one. Now, how it will work for you. So once the traffic approaches this subnet, it will process the traffic from top to bottom. For example, it will check the traffic that's coming in, that's trying to come into the subnet. Does it include HTTP or the HTTP traffic from anywhere? If that's the case, let's allow that. So the traffic, does it include, or it includes POP3 traffic from anywhere? If that's the case, let's block it, deny it. The traffic that's coming in, does it include the SSH from this range? If that's the case, let's allow that. The traffic that's coming in, does it include the SSH from this range? If that's the case, let's deny it. So it will just process the traffic from top to bottom. Now at the end, there's an star or asterisk deny rule. Asterisk is a rule number, type is all traffic, protocol all, port range all, source anything, deny. This asterisk deny rule will ensure that any IP address or the protocol that is not specified on the top of it will be blocked automatically. For example, in the protocols section, I haven't included RDP. So this asterisk deny will ensure that if the RDP traffic comes in, it is denied automatically because the RDP traffic is not in the list. So any protocol or the IP address, anything that's not mentioned on the top of it would be denied automatically to come in. Similarly, once the traffic wants to leave my subnet, it will see that, okay, the traffic that wants to leave doesn't includes HTTP or HTTPS to any sources. If that's the case, let's allow that to go out. Apart from that, any traffic would be blocked from going out from this asterisk deny rule. Okay, it will be blocked automatically. Okay, now the thing is, if I just show you the default access control list, let me show you. The default access control list will choose, I show you the inbound rules. In the inbound, the rule number is 100, type all traffic, protocol all, port range all, source everything it allows. So on the top, we allow all the traffic. So this asterisk deny rule is null and voided. It's of no use. Similarly, if you just go to the outbound, we have the rule number 100, type all traffic, protocol all, port range all, destination everything, and we allow it. So this star deny is null and voided. It's of no use. Hence, the default ACLs that you have, the default access control list that you have, will automatically allow the inbound, every traffic inbound and outbound, all traffic inbound and outbound. Hence, in the real situation, we don't go with the default ACLs, we go with the custom network access control list. That being said, this completes the entire conversation on the VPC. I thank you all for your time and patience. This completes all the topics on the VPC that are important from the Solutions Architect Associate examination point of view.